All right, everybody, we're back here for P.2. And this P.2 video is going to be talking about inequalities. So these inequalities are things that we have talked about really pretty heavily in Algebra 2. We had talked about when we put them on a number line, we're looking for overlap or we're not looking for overlap, what it means when we do have overlap, what it means when we don't have overlap. That's a conversation that's going to be better for us in the classroom. So right now I'm going to focus on solving the inequality, finding the values that we think could be correct, finding the values that we think might not be correct, because once you get there, that's 99% of the battle. And then actually figuring out whether it's all values, no solution, infinitely many solutions, that's stuff that we'll be able to talk about better in person so that you guys can ask questions on those. As I look through the book has some very confusing terminology compared to what we've been using. So I just want to make sure that I clear that up. So what that looks like is we might see, let me share my screen with you. We might see in here a few different types of what look like ordered pairs. These ordered pairs will look something along the lines of this, where it'll be like 3, 5, or it'll be 3, 5, oops, with a closed bracket. Or it might say like A, infinity, or it might say negative infinity, B, or something like this. What these brackets are, this thing is basically saying or equal to, and this one just means less than or greater than. So what you can really think about here is if I look at this value right here, this is saying values from 3 to 5, but not including 3 and not including 5. So it's saying the x is between 3 and 5, but we don't include 3, we don't include 5. This one is saying the values between 3 and 5, we don't include 3, we do include 5. This one is saying A all the way up to infinity. So this is basically saying greater than or equal to A. Okay. This one is basically saying everything from B and below. So less than or equal to B. All of the ones that have these closed brackets on here, those ones are called bounded intervals because that means that they stop at something. The ones that don't have brackets and they are, the ones that use infinity, those ones are unbounded. So really the ones that have some form of, and I shouldn't have said the closed brackets, I should have said that they have the numbers. So like if they have a number in it where it says something like this, where it's from 3 to 5, 3 to 5, if we have one that says like -7 to 14, if we have one that says like -3 to 2, and we close them like that, those ones are bounded because they actually specifically talk about numbers, right? So we have a bound. It's between -7 and 14. It's between -3 and +2. If you have an infinity in here like this, these ones are unbounded because if they use infinity, that means that they go on forever, just like this, like less than or equal to, greater than or equal to a certain number, and they just keep going on forever, okay? Or they just keep going forever in the negative direction. So that's going to be one that's a little bit tricky for you. Paying attention to whether things are bounded or unbounded. Bounded basically means that they have numbers and it's between two specific values. Unbounded means it goes on forever in one or the other direction. As we move to the next page in the book, we talk about properties of inequalities, and we talk about solving linear inequalities in one variable. I'm not going to spend any time on that because I'm going to get right into absolute value, because when we use absolute value, it uses linear inequalities anyway, okay? So if you remember way back to last year, we actually talked about inequalities and we used these things called logical equivalencies. We always wanted our absolute values to be in the form of something like this, where it was ax plus b is less than or equal to c. It's the same thing. Or we had the absolute value of ax plus b is greater than or equal to c. So this is what they look like. This one up here went along with an and statement, and I think the book calls them double inequalities. So this is when they're called and statements where we want to see overlap. These ones we called or inequalities, they call them compound inequalities. Okay, these ones are like greater than, no overlap. Okay, the logical equivalency, first off, the first thing I want to mention is you always get them in the form of absolute value, inequality, everything else on the other side. Absolute value, inequality, everything else on the other side. The way that this works is if you see this inequality, you do negative c, oops, let me take that away and redraw it. We have negative c is less than or equal to ax plus b is less than or equal to c. So you basically, if we cover this part up, it says ax plus b is less than or equal to c, which is exactly what it says up here. And then we basically just flip the sign and make it negative. Same thing is happening here. We'll take the first one and we won't change anything. Ax plus b is greater than or equal to c. And then we're going to take the exact same thing where we flip the sign and make the other side negative. Okay? All of these you're going to want to graph on a number line. When you graph them on a number line, you're going to see if the interval actually works. If it doesn't work, if there is overlap, if there's not overlap, that's what we're really paying attention to. So let's go through an example of that so we can see it. The example that I have here looks like this, where it is the absolute value of 2x minus 13, minus 3. Absolute value of 2x minus 3 minus 15 is less than 0. So the way I want to get this written is, ooh, come on, don't stop working now. So I have, come on. Give me a second. I'm going to try to reset this. Okay, hopefully we're good. So though I'm going to rewrite this with absolute value of 2x minus 3 is less than 15. And I want absolute value there and absolute value there. So absolute value of 2x minus 3 is less than 15. This is in the form that I want it to be in. I see that there's a less than symbol here, so I know it's going to go with the first logical equivalency that we talked about. It's going to be an and statement, so I want it to be negative 15 is less than 2x minus 3 is less than positive 15. I'm going to treat this like a totally normal equation, so I'm going to add 3 to both sides, all sides I should say. So it's going to end up being negative 12 is less than 2x, which is less than 12. Divide by 2 on all sides, and I get negative 6 is less than x is less than 6. Now, the main reason I want to be able to write these or put these into a number line is I want to make sure that it has the overlap that I'm looking for and that nothing is redundant. If I look on a number line like this, I'm going to see that I have the point negative 6 and positive 6. And I know that this is going to be greater than this way and less than this way, which means that it has exactly the overlap we're looking for. The way the book wants these written is it wants you to say it's going to go from negative 6 to positive 6. So x is between negative 6 and positive 6. And I want them to not include negative 6 or positive 6. So this is what it's looking for. Okay. There are examples of other ones as well in your homework. So check your homework. Make sure that you understand the compound inequalities as well. And we can go through those and talk about more examples of those in class if we need to. Okay. The next thing that I want to talk about is, and we didn't get to this that much last year, but it's pretty intuitive for you to understand how it works. So this is just solving quadratic inequalities. Quadratic inequalities look like this, where we have something like x squared minus x minus 12 is greater than or equal to 0. Same kind of idea. This one we don't have to do any logical equivalencies with because there's no absolute value. You only have to do the less than, greater than stuff when there's absolute value because you have 2 answers with absolute value. This one, I'm just going to do my thing. Okay, pretend that it's an equal sign, solve it like normal. So I'm going to factor this like I normally would. I want 2 numbers to multiply to negative 12 and add to give me negative 1. So it's going to be x minus 4 and x plus 3 is greater than or equal to 0. And then now, the hard part about this is I can't just use the inequality sign that I think I can use. Right now, I know my answers are going to end up being, this thing keeps going crazy. I know my answers are going to end up being x equals 4 and x equals negative 3. Those are my 2 answers. But I don't know if it's x is bigger than negative 4, x is less than negative 3, x is less than 4, x is greater than 3. I don't know. So the way that I'm going to do this is I'm going to put these on a number line. And then I'm going to test them. So I'm going to put negative 3 on a number line here. I'm going to put 4 on a number line here, and then I'm going to test certain numbers that are smaller than, in between, and bigger than. So I'm going to test the number -4, I'm going to test 0, and I'm going to test 5, because those are in between and outside of those values. Those are called key values, okay? Or I think that, what do they call them? They call them key numbers, maybe. Let me make sure that I call it the same thing so that we're all on the same page. Key numbers, they call them. So these are the key numbers. I used to call them critical values. But when you deal with these, you're just testing the numbers to see if they work. So I'm going to take -4 and plug it into this inequality and see if it works. So I'm going to do -4 squared minus -4 minus 12. And I want to see if that's greater than or equal to 0. So this is 16 plus 4 minus 12, which is going to be 8 is greater than or equal to 0. And that is true. It works there. Now I'm going to try the same thing with 0. 0. There's like a dead spot in this Moby. Okay. So I'm going to try 0. 0 squared minus 0 minus 12 is greater than or equal to 0. So that means -12 is greater than or equal to 0. Not true. And then I can pretty much assume that this one's going to work, but I'm going to test it just in case. 5 squared minus 5 minus 12 is greater than or equal to 0. So this just means 25 minus 5 is 20, minus 12 is 8 is greater than or equal to 0. This one's going to work too. The way that we would have written this last year is we would have said x is less than -3, or x is greater than or equal to 4. And I'm getting the greater than or equal to because of this thing here. The way your book will want you to write it is -infinity to -3, and it includes -3. Or it wants you to use the union symbol, or it's just like in truth tables, or, and then it's going to include +4 all the way up to +infinity. Now, if you're going to take upper level math classes next year, this is something you're going to have to pay attention to, because you have to use those boundaries next year, okay, or when you go to college, okay, because that's going to be a big deal. Finally, the last thing that we're going to talk about, because I know this video is kind of getting carried away and it's kind of getting long, but it's rational values, rational expression, rational inequalities. So what we want to do is we want to have something, or we have something that looks like this: x plus 12 over x plus 2 minus 3, actually we'll say is greater than or equal to 0. Nope. Is greater than or equal to +3. I don't know why I put the plus there. So if we have something that looks like this, same kind of steps that you have before. You want it to be equal to 0, and we're looking for our key numbers here. Your key numbers are solutions or numbers that make denominator undefined. So they are either solutions to the expression, or they are answers that make the denominator undefined. Those are the key numbers that we're going to be testing, and we're going to test them the exact same way that we just tested in the last one. Okay, so that being said, I'm going to write this in the form of x plus 12. I really wish this would work better. X plus 12 over x plus 2 minus 3 is greater than or equal to 0. I think it's just that spot. X plus 12 over x plus 2 minus 3 is greater than or equal to 0. Okay, so now what I want to do is I want to simplify this into one expression. The way that I simplify this into one expression is I have to have common denominators. So I'm going to go through and I'm going to find my common denominators. This already has a denominator of 1, so I don't have to worry about it. This one has a denominator of x plus 2. That's what I need to multiply by. So I'm going to multiply by x plus 2 over x plus 2. So this will turn into x plus 12 over x plus 2 minus, and then I'm going to put this in parentheses up here, 3 times x plus 2 over x plus 2 is greater than or equal to 0. So I'm going to get x plus 12 over x plus 2. And then I'm going to change this to a positive, and I'm going to distribute the negative. So plus negative 3x minus 6 over x plus 2 is greater than or equal to 0. And then I'm going to combine my variables. So I'm going to get x plus negative 3, which is negative 2x. 12 plus negative 6 is going to be a positive 6 over x plus 2 is greater than or equal to 0. So now basically I want to set the top and the bottom equal to 0 and find my critical values. So my top part, I want to know what number I can plug in here that will make the top 0. And I can pretty easily see that if I plug 3 into here, it turns into negative 6 plus 6. So I know x is going to equal negative 3, positive 3. X is going to be positive 3. In the bottom, if x equals negative 2, that makes this undefined. So there are my two values that I have to test. Okay, so my two values are negative 2 and positive 3. I'm going to do it again on the number line just like I did last time. So I have negative 2, I have positive 3, and I'm going to test these points. I'm going to test negative 3, I'm going to test 0, and I'm going to test 4. And I'm going to see what numbers work for these. Okay, so I'm going to test negative 3 when I plug negative 3 into here. All of these are equivalent to each other, so it doesn't matter which one you use because we haven't canceled anything. So if I plug negative 3 into here, I get negative 2 times negative 3 is positive 6, plus 6 is 12, over negative 3 plus 2 is negative 1, is greater than or equal to 0. So this is saying negative 12 is greater than or equal to 0, which is not true. I'm going to try the same thing with 0. Negative 2 times 0 is 0, plus 6 is 6. Over 0 plus 2 is 2, which is 3. 3 is greater than or equal to 0, so that works. And then the last one is 4. Negative 2 times 4 is negative 8, plus 6 is negative 2. Over 4 plus 2 is 6, greater than or equal to 0. All I care about is that this is negative, and a negative is not greater than, so that's no good. So the last thing I really have to check, I have to see if these values do work. I have to see if those values work and if they make it true. So if I plug in, because I know that right now my interval is going to look like this, negative 2 to 3. But I have to know if I'm going to put open parentheses or closed brackets behind it. So when I take my value, negative 2 or positive 3, I'm going to plug it back in. I know negative 2 is not going to work. If I try to use negative 2 here, negative 2 is going to end up giving me an undefined here, and that's not going to be okay, so I cannot include negative 2. But if I use negative 3, I get 0 in the numerator, and I don't care what in the denominator as long as it's fine, and then I don't have to worry about it. So this for sure is going to work. So I know every value from negative 2 to positive 3 is going to work, including positive 3. So that's what you're looking at there. Okay, that's going to be enough to get us started and to really work through these problems. We're going to spend a day or two talking about these to make sure we understand what's going on. And then we're going to move on into a couple different things. So this should be enough to get you started. Check your homework or check Google Classroom for your homework. And let me know if you have any issues. We will talk about as many of these as we need to, but you guys need to make sure that you ask questions on things that don't make sense. Okay, so if you have any questions, let me know. Otherwise, good luck and have fun.